Here are some examples on square root addition or subtraction. For this first one, we have 4 times the square root of 27 plus the square root of 48. The first step before we can add or subtract is we want the radical to be like. So we want what's underneath the radical to be the same number, otherwise we can't add or subtract them. And so to do that, we're going to simplify the radicals. So whatever's out in front just comes down, and then I'm going to break apart the square root of 27. So we're looking for factors that are perfect squares. And so numbers you're looking for would either be are they divisible by 4, 9, 16, 25, 36, etc. Typically, you're going to be, looking for these first three unless it's a larger number under the radical. So in this case, if I look at 27, I know 27 is divisible by 9. And then I would need to do 9 times 3 to get 27. So I can break apart the square root of 27 into the square root of 9 times the square root of 3. And then I'm going to break apart 48 as well. And 48 is actually divisible by 16 and 3. So there's other ways to get to 48, like 8 times 6 might have come to mind first, but again, we're looking for one of these numbers, either 4, 9, 16. Those would probably be what you're looking for most of the problems, and then, any other square number like 25 or 36 would also be helpful. And once I've found what they break apart as, I'm going to go ahead and simplify. So again, I'm going to bring down that 4. The square root of 9 is just 3. Square roots of 3 plus the square root of 16 is just 4. Now I'm going to simplify this. I'm actually going to multiply 4 times 3. So now I have 12 square roots of 3 plus 4 square roots of 3. And so now that we actually have it matching up, there's 12 square roots of 3 and then 4 more square roots of 3. I can get my final answer of 16 square roots of 3. So the simplifying is the trickier part right here. Once we figure out what we can break our numbers apart as and we can get our matching pieces under the radical, then it becomes a little bit easier. So for the second one, here's a subtraction problem. I'm going to bring down that negative 4 and then I'm going to break apart 80. Again, what came to mind first might have been like 8 and 10, but again, we're looking for is it divisible by 4, 9, 16, etc. And 80 is divisible by 16 and 5. And we're going to subtract and breaking apart 20, I'm going to break that apart with 4 and 5. So again, that part's probably the hardest. You have to do maybe some checking. If you don't know your math facts very quickly, you might want to use a calculator and kind of see, well, what is 80 divisible by? Is it divisible by 9? No. Is it divisible by 16? Yes. And actually, 80 is divisible by 4, but that would create extra steps, so I can show that as well. But let me finish it up here. Negative 4, and then square root of 16 is 4. Square root of 5 minus square root of 4 is 2. I'm going to multiply here and I get negative 16 square roots of 5 minus 2 square roots of 5. Using our integer rules now, negative 16 minus 2 more gives me negative 18 square roots of 5. And that's the final answer. Now I did mention you could break apart 80 with a 4. So you would do square root of 4 times square root of 20, which works, but then you can also break apart 20 again. So then you'd end up with 2 times 2 times the square root of 5. Which gives you 4 square roots of 5, which is what we got right here. So you can technically do that. It just takes more work. So you kind of you want to find the largest square number that the radicand can divide by. I hope that these videos help clarify how to add or subtract square roots.